In this example, we're asked to find the absolute min and max of the function f of t equals 2 times the cosine of t plus the sine of 2 times t on the closed interval from 0 to pi over 2. Those are intervals of t values. To answer this question, we'll be using the 30, 60, 90 triangle, which is written here in radian form, pi over 3, pi over 6, and pi, with the sides 1, 2, square root of 3 as labeled here. We'll use the definition of sine and cosine on a right triangle. We'll use the sinusoidal waves for the sine of x and the cosine of x, and we'll also be heavily depending on note number 70. So the first thing we want to do is make sure that note 70 applies here. Well, notice that since f of t is continuous as a combination of the sine cosine function on the closed interval of t values from 0 to pi over 2, including the endpoints because it's closed, we are now allowed, according to the supposition, to use note number 70. Now let's consider the first step for note number 70. Find the critical numbers of f of t. Well, you recall that you find the critical numbers by finding the zeros of the first derivative of the function. So you set f prime of t equal to 0 and you solve for t. Those t's are your critical numbers. F prime of t here is equal to negative 2 times the sine of t plus the cosine of 2t, and then hit it with the chain rule, times 2. That's a derivative of the given function. Factor out negative 2, you get parentheses sine t minus cosine 2t. And now we have a problem. We go, uh-oh. We want only one trig function with only one argument. We have two arguments here. The argument for sine is t. The argument for cosine is 2t. Let's just get one argument t for one trig function, one type of trig function, sine. And to do that, we're going to use the double angle formula. Specifically, cosine of 2 times t equals 1 minus 2 times sine squared t. There's a couple of different forms of the double angle formula, but this is the one that will do what we need it to do. So substituting that, we get f prime of t is equal to negative 2 parentheses sine of t minus parentheses 1 minus 2 sine t squared. Sine t squared is the same as sine squared t. That's negative 2 parentheses 2 sine t squared plus sine t minus 1. It looks like a polynomial. Let x be the sine, and then we can factor this easily. Then we'll go back to sines. If we let x equal sine, we can factor this as negative 2 times, bracket, 2x minus 1 times x plus 1, where x is sine t. You can check that to see that it's good. Then f prime of t set equal to 0 will give us negative 2 parentheses 2 times sine t minus 1 parentheses sine t plus 1. We went back to the value for x equals 0. Okay, it's already factored. It's equals to 0, so set each of the factors equal to 0. Negative 2 times 0 is nonsense. Equals 0. That's nonsense. Throw that away. The other ones are good. Solving for t, we get sine t equals 1/2 and sine t equals negative 1. We have to find the values t that make this correct. And first we'll find the solutions for these two equations on the closed interval from 0 to 2 pi, because that's one period for the sine function. On that interval, let's find the t whose sine is 1/2. Well, just look at the 30, 60, 90 triangle. You see that t equals pi over 6, where sine is opposite over hypotenuse. That gives you 1/2. And you also notice that on the interval from t equals 0 to t equals 2 pi, we get that value for t, the sine of t twice, at pi over 6 and 5 pi over 6. So we have two solutions for that. And then for sine t equals negative 1, you just look at the sinusoidal wave and you see t equals 3 pi over 2 on 0 to 2 pi to give you sine t equal negative 1. Well, now we eliminate the solutions that are not in our restricted domain, which was given to us to be 0 to pi over 2, which means we're only going to keep t equals pi over 6. The other two answers are not on our domain. Step 2, find the the function evaluated on the critical numbers. I'm talking about the original function, not the derivative function. Find the function evaluated on the critical number. Well, there's only one critical number here. It's pi over 6. So evaluate f of pi over 6. That's 2 cosine pi over 6 plus sine of 2 times pi over 6, which is 2 times square root of 3 over 2 plus square root of 3 over 2. And together that gives us f of pi over 6 equals 3 square root of 3 over 2. That's called the critical value, and by evaluating the function at the critical number pi over 6. So the critical value is 3 square root of 3 over 2. Step 3, find the function evaluated at the endpoints. Well, the endpoints a, b are 0, pi over 2. So first, f of a would be f of 0. That's 2 cosine 0 plus sine of 2 times 0, and that just gives you the value 2. Then the function evaluated at the other endpoint, that's f of b, which is f of pi over 2. That gives you 2 cosine pi over 2 plus sine 2 times pi over 2, and that gives you 2 times 0 plus 0, which is 0. Okay, so now we're ready to conclude step 4. These are the steps of note 70, by the way. F of c, f of the critical points, gave us 3 times the square root of 3 over 2. And f of the endpoint A gave us 2, and f of the endpoint B gave us 0. So those are our three values. According to note 70, the largest of these values will be our absolute max, and the smallest of these values will be our absolute min. This only works for continuous functions on a closed interval, this method that we're using, these 4 steps. So it turns out that the 3 square root of 3 over 2, that's the critical value for the critical number pi over 6. That's our absolute max. And f of what was that? Pi over 2 equals 0. 0 is our absolute min. That's the critical value that's a value of the function evaluated at one of our endpoints. So the answers are absolute max, 3 square root of 3 over 2, absolute min, 0. Those are not t values, those are f of t values.